Okay, camera. Okay, lesson 26, factoring complex trinomials. So this morning we're going to learn to factor a complex trinomial by using the method of decomposition. Okay, so instead of just being like a one-step process, there's 3 steps. A lot of people like this one because there's specific steps to do. I can apply the factoring to change a parabola from standard form to vertex, or to intercept form, sorry. So expand and simplify. So if we were going to expand this, we would use FOIL. So if we multiply our firsts together, we would get 6x squared. Outsides, positive 8x. Insides, positive 9x. And last is positive 12. And then these are like terms, so we can collect them. And this is what we would consider a complex trinomial. So a complex trinomial has an a value that's not 1 and is also not common to the other 3, all 3 terms. Okay, so when you're identifying the difference between a simple trinomial and a complex trinomial, first of all, if there's a number other than 1 in front, it could definitely be a complex trinomial, but then you want to check, is that number common to all 3 terms or not common to all 3 terms? If it's not, then we consider it a complex trinomial. And you can see how we're going to be learning to work backwards. And you can see how the factors don't just start off with plain x, they start off with a number in x. Okay, and we have to be able to figure out what those numbers are. You can see 2x times 3x gives you 6x squared, but we have to be able to do that in a way that also makes the middle terms and the last terms work out. Okay, and that's using the method of decomposition will always work for that. So that's what we're going to learn. So factor the following complex trinomial using the method of decomposition, and then we're also going to check our solution using FOIL. So again, this is a list of steps that we're going to learn how to do this morning, and then hopefully everybody will be able to do it. Okay, you may think, why are we doing this? But hopefully once we get to the end, you'll understand how this is a method that works. So the first thing you do, may seem weird, is you multiply the first term and the last term together. So I'm thinking in my head, 3x squared times 20 is 60x squared. So I multiplied the first term and the last term together, and I did it off to the side. And now, similar to yesterday, I want to find, instead of just 2 numbers that multiply to 60, I want to find 2 terms that multiply to 60x squared. But not only do they have to multiply to 60x squared, similar to yesterday, not exactly the same, they have to add up to 17x. Okay, positive 17x. So in order to multiply to 60x squared, each of them have to end in x. That we should know, because x times x gives me that x squared I need up here. And then if I multiply some number x plus another number x, that's what could give me my 17x. So if I'm multiplying to a positive and also adding to a positive, both of my numbers could be positive. So I could start off with my 1 times table, but 1x plus 60x is 61x. So that's not the pair. I'm looking for 17. Okay. I could try 2x and 30x, but that adds up to 32x. So also not the pair. 3x and 20x adds up to 23x, also not the pair. 4x and 15x adds up to 19x, also not the pair. 5x and 12x does add up to 17x, so that's the pair. And again, if you don't remember how to, like if you don't just know those in your head, you can just do 60 divided by 3, and that gives you 20. So there's your 3 and 20. 60 divided by 4, is 15. So there's your 4 and 15. Okay? You just keep trying that to get your factors. So once you have these, we go back to our original question here, and we're going to copy out the 3x squared. And then we're going to look at the two terms that we chose, and we're going to ask ourselves from a common factoring point of view, what has more in common with 3x squared? 5x or 12x? And I would choose 12x because I know 3 goes into 12. So I'm going to put the 12x next, so plus 12x. And then I'm going to put the one I didn't use, plus 5x, plus 20. And there's my plus 20, and there's my 3x squared. So all I did, these two statements are equal because all I did was break up or decomposition. I broke up the term 17x into positive 12x plus 5x. So these two statements are the same, but what I've done doing this decompose step is set this up to factor by grouping, okay? So once you've done that step, we can factor by grouping like we learned how to do yesterday in the first lesson, where we just look at the first two terms and see what's in common with just the first two terms. So if you just look at the first two terms, 3x squared and 12x, they have 3 in common, and both terms have an x, and the smallest exponent on the x is an x, is a 1, sorry. So just for the first two terms, 3x is common. And then I want to go ahead and common factor just the first two terms. So what would I need to multiply 3x by to get 3x squared? X. What would I have to multiply 3x by to get positive 12x? Positive 4. Now the sign that comes next goes next, so positive. And then I look at my second two terms, 5x and 20. And I see what's in common with just those two terms. Well, I know 5 goes into 20. Both of them don't have an x, so my common factor is positive 5. So then I'm thinking, what do I multiply positive 5 by to get positive 5x? X. What do I multiply positive 5 by to get positive 20? Positive 4. So if you've done the first two steps correctly, a good check is that your binomials will match. Okay, so you get this binomial common factor. So right now you've got two big terms, or two big chunks, and they've got this binomial x plus 4 in common. So that's my common factor. And then just like in grouping yesterday, the leftovers, 3x plus 5, form the other factor. So now it's factored. One binomial multiplying another binomial. So I've changed something that was just adding into a product. And decomposition always takes the 3 steps that you show with equal signs. A couple people forgot their equal signs yesterday, so be aware of that. Okay, so now we're going to check and make sure that that's the answer. So to check it, we would use FOIL. So we're going to expand this and make sure we get back 3x squared plus 17x plus 20. So x times 3x first is 3x squared. X times positive 5 is positive 5x. Positive 4 times 3x is positive 12x. And positive 4 times 5 is positive 20. And then these are my like terms, so I can collect them. So 5x plus 12x is 17x plus 20, which is what the question was, which means that this is the right factorization. So that's the main idea of this morning's lesson. We're gonna practice some more, do some ones that have negative signs, but that's gonna always be our same 3 steps that we have to do. Okay, so factor each complex trinomial using the method of decomposition. So all positive, which is nice. I see there, it tells me it's a complex trinomial, but if I was checking, I would say there's a 2 there and 2 doesn't go into all 3 terms, so it's a complex trinomial. So then your first step is to multiply the first term by the last term. 2x squared times 10 is 20x squared. And I want to add to positive 9x. So both of my terms will have to be positive. So they could be 1x and 20x, because that multiplies to 20x squared, but it adds to 21x, so it's not them. So then I would try 2x and 10x, because that multiplies to 20x squared, but it adds to 12x, so it's not them. 3 doesn't go in evenly to 20. 4 goes in 5 times, so 4x and 5x. Yes, because they add up to 9x. So then I'm going to rewrite my 2x squared, the first term. And then I'm going to look at 4x and 5x and decide what has more in common with 2x squared. From a common factoring standpoint, 4x has more in common because 2 goes into 4. So I'm going to put the 4 plus 4x down next, and then the plus 5x, and then the plus 10. So that's my decomposition step, where I decompose or break down 9x into 4x plus 5x. So now I've created a grouping, a factor by grouping question, where I group the first 2 terms and see what's in common with them. So 2 is common to both, and there's an x in both. Smallest exponent is a 1. And then what do I multiply 2x by to get 2x squared? X. What do I multiply 2x by to get positive 4x? Positive 2. Close your bracket. Now the sign that comes next goes next. What's in common with the second 2? 5x and 10, 5. So then I'm thinking, what do I multiply positive 5 by to get positive 5x? X. And what do I multiply positive 5 by to get positive 10? Positive 2. So if you've done the first 2 steps correctly, then you get a binomial common factor. These have to match, in other words. And if they do, you should be pretty sure you have factored it correctly. And then the leftovers form the other factor. And there you are, fully factored. Okay, so that's decomposition. Next example. So again, it's a complex trinomial because that's not a 1. And also the 6 doesn't go into all 3 terms, so we know we're going to use decomposition. So multiply 6x squared by 4, and that gives you 24x squared. And you want to add to positive 11x. So 1x and 24x does not add up to 11. 2x and 12x does not add up to 11. 3x and 8x does add up to 11. Okay, so now that you've got your terms, recopy your 6x squared down and then see from a common factoring standpoint what you think has more in common. So I'm going to say 3x is 3 and 6 are common factors, plus 8x plus 4. So now you've created factoring by grouping. So you group your first two and see what's in common with just the first two terms. So 6 and 3 have 3 in common. They both have an x. Smallest exponent is a 1. And then you do your, what would you need to multiply 3x by to get 6x squared? And you should get 2x. Be careful there. It's not just x like it has been in the previous two examples. 3x times 2x is 6x squared. Plus, this is also, what would you multiply 3x by to get 3x? 1, not 0, which is a common mistake. 3x times 1 is 3x. Then the sign that comes next goes next. And then you're looking at what's in common with 8x and 4. 4 is in common. What do you multiply 4 by to get 8x? 2x. What do you multiply 4 by to get 4? 1. And then here's where, if you did everything right, you get a common binomial. So your common binomial is 2x plus 1, and your leftovers form the other bracket. Okay, next one. Complex trinomial. Multiply the first by the last. And you get 60x squared. Okay, I'm going to give you a minute, see if you can come up with the numbers that are the terms, that would multiply to 60x squared and add to 19x. So I got 4x and 15x. So then I'm going to look at my two terms I found and see which one has more in common with 10x squared. I would say 15x, so plus 15x. And then the one I didn't use, plus 4x, and then plus 6. So again, this first step is you're rewriting 19x as 15x plus 4x. And that's to create factoring by grouping. So then you want to group your first two terms and see what their greatest common factor is. So the biggest number that goes into 10 and 15 evenly is 5. And there's also an x in both terms. And then to go in the bracket, what do you need to multiply 5x by to get 10x squared? 2x. And then what do you need to multiply 5x by to get positive 15x? Positive 3. Then you need the plus sign to come next. And then what's in common with 4x and 6? 2, hopefully you say. 2 times what gives you positive 4x? 2x. And positive 2 times what gives you positive 6? Positive 3. Common binomial, yay. Common binomial is your common factor, and the leftovers form the other bracket. Okay, and D is going to be our last one with all positives, and then we'll introduce the negative sign. It doesn't affect the steps. It may just be a little more challenging to find out your pair. So we want to add to 13x. So we'll start off with 1x and 12x. Yay, that's the pair. All right, so found it on our first try. What has more in common? I'm going to say 12x has more in common with 4x squared. So then we set up our factoring by grouping. The first two terms have 4x in common. And 4x times x is 4x squared. 4x times positive 3 is positive 12x. Sign that goes next comes next. The second two terms just have 1 in common, okay? What do you multiply 1 by to get 1x? X. What do you multiply 1 by to get 3? 3. And you do get this common binomial again. So your common binomial is x plus 3, and the leftovers form the other factor. All right, so that's factoring by decomposition. We've done a number of examples. Now it's going to get a little more challenging because of the negative signs, but we're still doing the same thing. So again, I am seeing this as a complex trinomial because it starts with a 2 in front of the x squared, and 2 is not common to all of the terms. So your first step is still going to be to multiply the first by the last, but this time you're multiplying 2x squared by negative 15. So that gives you negative 30x squared. And then you want to come up with two terms that multiply to negative 30x squared and add to positive 1x. And whenever you're multiplying to a negative, you need one positive and one negative. Since you're adding to a positive, the bigger one is positive. We know they're both going to end in x. So if we have 1 and 30 and we said the bigger one has to be positive, it would be negative 1x and positive 30x. But that adds up to 29x, so it's not them. Negative 2x and positive 15x adds up to 13x, so not them. 4 doesn't go in evenly. Negative 5x and positive 6x does add up to positive 1x. So that's your combo. So then we still write down our 2x squared, and we still look at our two terms and see which one has more in common with 2x squared. I'm going to say positive 6x. And then the one I didn't use was the negative 5x. That comes next. And then negative 15. So that's my decomposition step. I still just rewrote positive 1x as positive 6x minus 5x, so they're equal. But I created 4 terms so that I can factor by grouping. So I start off just by looking at the first two terms and see what they have in common. They both have 2 in common and x. What do I multiply 2x by to get 2x squared? X. What do I multiply 2x by to get positive 6x? Positive 3. Okay, so here's really important. The sign that comes next goes next. Okay, that's a really important step. And then you're looking at what's in common with 5x and 15? 5. But now your common, your common factor is not 5, it's negative 5. So you're thinking to yourself, what do I multiply negative 5 by to get negative 5x? That's just x, because negative 5 times x is negative 5x. And what do I multiply negative 5 by to get negative 15? And if you're not sure, then on your calculator, you can do negative 15 divided by negative 5, and that's positive 3. Negative 15 times positive 3, sorry, my bad. Negative 5 times positive 3 is negative 15. Okay, so if you use your signs correctly, you'll get the common binomial with the correct signs again. There's your common binomial x plus 3, and the leftovers 2x minus 5 form the other factor. All right, so here's another question. This time the negative sign's in the middle. So I'm still doing first term by last term. 5x squared times 8 is 40x squared. But I'm adding to a negative. So the only way to multiply to a positive but add to a negative is if both terms are negative. So I could have negative 1x and negative 40x, but that adds up to negative 41x, not negative 14x, so it's not them. Negative 2x and negative 20x adds up to negative 22x. 3 doesn't go in. Negative 4x and negative 10x does add up to negative 14x, so it's them. So I'm going to recopy my 5x squared. What's got more in common with 5x squared? Negative 10x does, so that goes next. Then the negative 4x, then the plus 8. So now you've decomposed the negative 14x so that you can factor by grouping. So you're looking for what's in common with the first two terms. So 5 is and x is. What do you multiply 5x by to get 5x squared? X. What do you multiply 5x by to get negative 10x? Negative 2. Sign that comes next goes next. That negative has to go there. And then you're looking for what's in common with 4x and 8. It's 4. So now you're looking at this number as negative 4. So what do you multiply negative 4 by to get negative 4x? X. Negative 4 times x is negative 4x. What do you multiply negative 4 by to get positive 8? If you're not sure, you're going to do positive 8 divided by negative 4. And that gives you negative 2. Negative 4 times negative 2 is positive 8. And then you look at your binomials and you realize that they're the same. And you get all excited. So there's your common binomial, and the leftovers 5x minus 4 form the other factor. Okay, for C, we have negative signs, but we also have a different variable other than x. Still have the same first step. 4m squared times negative 8 is negative 32m squared. And we want to add to negative 31m. So if we're multiplying to a negative and adding to a negative, the bigger term needs to be negative. So if we do 1 and 32, the bigger one, so the 32 has to be negative. And it turns out that 1m plus negative 32m is negative 31m. So that's my pair. So I'm going to write 4m squared down. And what has more in common? Well, I know 4 goes into 32, so I could choose negative 32m here. Then plus 1m minus 8. So now you've created factoring by grouping. And you're looking for what's in common with just the first two terms. So 4 and m. Here you want to, what do you multiply 4m by to get 4m squared? M. And then if you didn't know what to multiply by, you would do negative 32 divided by 4, and it's negative 8, so minus 8. So 4m times negative 8 is negative 32m. Sign that goes next comes next, so positive. What's in common with 1m and 8 is just 1. What do you multiply positive 1 by to get positive 1m? M. What do you multiply positive 1 by to get negative 8? Negative 8. Positive 1 times negative 8 is negative 8. You get the common binomial, and the leftovers form the other bracket. Okay. All right, now we have ones that have the AB and the B squared. Same thing, we still multiply the first and the last. So 6a squared times negative 2b squared is negative 12a squared b squared. So in order to multiply the two terms and get the ending to be a squared b squared, our two terms both have to end in ab. And we're multiplying to get a negative, and we're adding to get a negative 1. When you're multiplying to get a negative, one has to be positive and one's negative. If you're adding to a negative, your bigger one's going to be negative. So 1 and negative 12. So 1ab plus negative 12ab would be negative 11ab. So that's not your pair. 2ab and negative 6ab add up to negative 4ab. So that's not your pair. 3ab and negative 4ab do add up to negative 1ab. So that's your pair. Okay, so you're still going to copy down your 6a squared first and look and see what has more in common with 6a squared. And I would say it's the 3 because 3 goes into 6. So plus 3ab. Then the one you didn't choose, minus 4ab. And then your last term, minus 2b squared. So now you've created factoring by grouping, where you just want to look at what the first two terms have in common. So just the first two terms, they have 3 in common. They both have an a, and the smallest exponent on a is a 1. They don't both have a b, so b can't be part of your common factor. So your common factor for just the first two terms is 3a. Then you want to think, what do you multiply 3a by to get 6a squared? So that would be 2, because 3 times 2 is 6, and a, because a times a is a squared. And then you're going to look at, what do you multiply 3a by to get 3ab? Well, you already have the 3a, so it's just b that you would multiply by. So 3a times b is 3ab. Then the sign that comes next goes next. And then you're looking to see what these two terms have in common. So I'm looking at their numbers, 4 and 2. 2's in common. They don't both have an a, so that's not common. They do both have a b, and the smaller exponent is b. So now I'm looking at this term as negative 2b, and I'm thinking, what do I multiply negative 2b by to get negative 4ab? So if I wasn't sure about the number, I would do negative 4 divided by negative 2 is positive 2a, and negative 2b times 2a is negative 4ab. So I'm good. And then what do I multiply negative 2b by to get negative 2b squared? Positive b, because negative 2 divided by negative 2 is positive 1. So I did that right. So my binomials should be common, and they are. And the leftovers, 3a minus 2b, form the other bracket. And remember, I could always expand to see if this is correct or not. So anytime you get one of these questions, you could have like scrap paper, especially like for the assignment or whatever, and make sure that your questions are right. So 2a times 3a is 6a squared. 2a times negative 2b is negative 4ab. Positive b times 3a is positive 3ab. Positive b times negative 2b is negative 2b squared. And then I have 6a squared. Collect these terms because they both end in ab. Negative 4ab plus 3ab is just negative 1ab or negative ab minus 2b squared. And that's what we started with. So we know that this is correct. So anytime you're unsure, expand and use FOIL, and you'll be able to see whether you factored it correctly or not. Okay. E, so similar where we've got the two terms. The y squared at the end and the xy in the middle, two variables, I should say. So 2x squared times 7y squared is 14x squared y squared. And I want to add to a negative, but multiply to a positive. So both of my terms have to be negative. So I could have negative 1xy and negative 14xy. But that adds up to negative 15xy, so it's not those. Negative 2xy and negative 7xy do add up to negative 9xy. So those are my pair. So I write out the first term, 2x squared. Obviously, negative 2xy is more in common because they both have 2. Then I put the minus 7xy and then the plus 7y squared. All right, and then I've got factor by grouping going on here. So what's in common with the first two? 2 is they both have an x. X to the 1 is the smallest exponent. They don't both have a y, so 2x is my common factor. Then I'm looking at what do I multiply 2x by to get 2x squared? Just x. What do I multiply 2x by to get negative 2xy? Negative y. So check that 2x times negative y is negative 2xy. Sign that comes next goes next. And then I'm looking at my last two terms and what they have in common. They both have 7. They don't both have an x, but they do both have a y. And the y to the 1 is the smaller exponent. So then I'm looking at what does negative 7y, what do I multiply negative 7y by to get negative 7xy? Just x. And what do I multiply negative 7y by to get positive 7y squared? So a negative times a negative gives you a positive. So it should be negative 1. You don't need to write the 1. Y. And then check it over. Negative 7y times negative y is positive 7y squared. You get your common binomial. And your leftovers form the other bracket. Okay, 5 is kind of a challenging question. But it highlights something that's really important, and that is that you should always check for common factors first. As we learn more and more types of factoring, this is going to become my mantra, check for common factors first. So if you look at this one, all of the numbers are even, which means at least 2 goes into all of them. And You could check 4, but 4 doesn't go into 14, so 2 is common. And they all have an M as well. So 2M is common to all of them. So your first step is to common factor out the 2M. So 24mx squared divided by 2m is 12x squared. Or what do I need to multiply 2m by to get 24mx squared would be 12x squared. And then what do I multiply 2m by to get 14mx? It would be 7x. And what do I multiply 2m by to get negative 20m? Negative 10. So that's just the common factor step. All I did there was common factor. So now you're going to look inside the bracket now and see if what's inside the bracket can be factored further. And you should see that it looks like one of these questions, maybe even on the page before this. It looks like, nope, that's from the assignment. Sorry, guys. It looks like one of these. Okay, so it looks like a complex trinomial, which means that I can continue factoring inside this bracket. So it's going to require some nested brackets, but my next step would be just looking inside the bracket here. I'd realize I need to do decomposition, and I'd multiply the 12x squared by the negative 10 and get negative 120x squared. And I want to add up to positive 7x here. So I know that my bigger term would have to be positive. So I'm not even going to write down 1 and 120 because there's no way they add to 7. 2 and 60 don't. So I'm just going to get my calculator out here until I start getting close. 120 divided by 3. 3 and 40, no. I want to get to 7. 120 divided by 4. 4 and 30, no. 120 divided by 5. 5 and 24, not near 7. 120 divided by 6. 6 and 20, they have a difference of 14, getting closer. 7 doesn't go in. 8 and 15, they have a difference of 7. So my bigger number has to be positive. So negative 8x and positive 15x. Multiply the negative 120x squared, and they add to positive 7x. So I still have my 2m, that's my common factor, still have my bracket. Now I'm going to decompose the 7x. So what has more in common with 12x squared, negative 8x, or 15x? Negative 8x, because they both have a 4 in common. Then plus 15x minus 10. Still need my 2m common factor up front here, but now I'm going to factor by grouping inside the bracket. So what's in common with 12x squared and 8x? 4 for the numbers and x for the variables. So I'm starting to see this nested bracket here. So what do I multiply 4x by to get 12x squared? 3x. And what do I multiply 4x by to get negative 8x? Negative 2. Then I'm looking at the sign here, plus. Sign that comes next goes next. And then I'm looking at what's in common with 15x and 10. 5. So it's a positive 5. What do I multiply positive 5 by to get positive 15x? 3x. And what do I multiply positive 5 by to get negative 10? Negative 2, closing bracket, and then this closing bracket. So this and this, open and close. Here's an open and close, and here's an open and close. So I still have my 2m out front, but then I notice that I have this common binomial. So that's my binomial common factor. It goes next. 3x minus 2. And then my leftovers, 4x plus 5, go next. So I've got 3 things multiplying together, my common factor 2m. And then when I did the decomposition inside, I had a binomial common factor, 3x minus 2, and then the leftovers, and they're all multiplying. Whereas here they were all adding and subtracting. That's more like, that's a really hard question. Probably not going to be one like this on any assignment, but it's important for grade 11 to at least have seen it once, even if you're not all the way there by the end of this unit. I know it's not ideal. Okay, our last question. It's to apply this to sketching a parabola in intercept form. Sketch the quadratic function y equals 2x squared plus 9x plus 7 by first changing it into intercept form. Okay, so muscle through this. This is our last question, but it's important as well. We're going to go over the graphing again the next time I see you on Monday, which will hopefully be in person, but I do want you to have an idea of it. So the first thing you would do on one of these questions is you would see if the 2 was common, because that would be the best case scenario, but it's not. So then you have to do decomposition. It's all positive at least, that's nice. So you need 2 terms that multiply to 14x squared and add to 9x. It's not 1x and 14x, but it is 2x and 9x. So keep your y equals, there's my 2x squared, 2x has more in common, then plus, oops, this should have been a 7 over here. My bad. 2x times 7x is 14x squared, 2x plus 7x is 9x. Common, factor the first 2. So 2x is in common. What do you multiply 2x by to get 2x squared x? Careful, what do you multiply 2x by to get 2x? 1. Sign that comes next goes next. 7's in common with the last 2. To get multiply positive 7 to get positive 7x, you multiply by x. And to get positive 7, you multiply by 1. So then you have this binomial common factor. And the leftovers form the other bracket. This is called factored form, not intercept form. Intercept form, remember, looks like this. Write it down here. The a is out front, and we know a is 2. And then we have 2 brackets that show us what our x-intercepts are. Okay? This is factored form. It's not intercept form because that 2 is still in one of the brackets, not where I want it to be, which is out front here. Okay? So we do a little bit of manipulation here. First, it doesn't matter what order these brackets are in, so I'm going to put the one with the 2 in front. Now I'm going to what we call force factor. So I'm going to get a blank page for a second. So force factoring is when we have to take that 2 out because it's a step number, but it doesn't go into 7. So I'm common factoring the 2 out no matter what happens. So what do I multiply 2 by to get 2x? X. But what do I multiply to get 2 by to get 7? It's not going to be a nice number, but we have to do it because we have to get that 2 out to be an intercept form. So 7 divided by 2 is 3.5, and usually it'll end up being a 0.5. So see, these are equal because if I expanded it out, 2 times x gives me 2x, and 2 times 3.5 gives me 7. So this isn't pretty, but it is factored out, and it gets that 2 out of the bracket. So I'm going to do that. I'm going to force the 2 out. But that means in this one bracket here, I would have x plus 3.5. So now, doing those steps, I've now put it in intercept form. So I know my step number is 2, which means up to 6 and 10. My intercepts, because there's plus signs in here, are going to be negative 3.5 and negative 1. Because it's the opposite sign. If there's a plus there, it would have had to be because it was x minus negative, right? So now you can mark those on your graph. So negative 1, 2, 3.5 is here. And negative 1 is here. Those are my x-intercepts. Then to find h, I add my x-intercepts together and divide by 2. So that's going to be negative 4.5 divided by 2, or negative 2.25. And then I have to sub that into this formula to get k. So k is going to be 2 times negative 2.25 plus 3.5 times negative 2.25 plus 1. Now I'm going to go to my calculator. Negative 2.25 plus 3.5 is 1.25. And make sure you can see that on the screen. Negative 2.25 plus 1 is negative 1.25. Then multiply those three numbers together. So 2 times 1.25 times negative 1.25 is negative 3.125. So that means my vertex is at negative 2.25, which is negative 2.25, negative 3.125. So here's negative 1, negative 2.25 is before the halfway, negative 1, 2, 3, and a little bit. So there's my vertex-ish right there. Okay? So it's not pretty, but we're just going to see if we've done it right by applying our step number. So let's see if we go over 1, we'd be like here. So this is a quarter of the way into this square. So over 1 would be a quarter of the way into the 1 square. Up 2 would put us right here. And then here over 1, we're going to be a quarter of the way into this square. Up 2. And then our next step is going to be over 1, up 1, 2, 3, 4, 5, 6. Over 1, up 1, 2, 3, 4, 5, 6. So when you join them, it should look like you go right through your intercepts on your way through, which it does. And there's your intercept form. And then the question, what makes this parabola difficult to sketch? The decimal coordinates, for sure. Okay, so I'm not going to have you like next week when we kind of focus on this for a day, there'll only probably be one of these more difficult graphs to draw where you have to force factor the step number out, but it is something that's part of the course. Okay, so our success criteria then is to use decomposition to factor a complex trinomial. I'm going to X out of here now. Hi, everyone. I'm going to stop recording and then I'm just going to talk to you for a second. And then you can go on and do the practice. Stop recording. Okay, so what you're going to work on now is the practice. I think this was 24, was it not? Yep, or sorry, 26. So work on practice 26. Check your solutions. I'll post them in a minute. And then you're going to go on to watching the video for lesson 27 on difference of squares. Okay. Check back in with me at 12:30. Make sure you don't try the check-in until after you've done the next lesson in practice. Okay. Because it's just on the next type of factoring you're learning. And then remember, use the Meet as a drop-in if you're having difficulty. Okay. So I'll see you at 12:30. Caleb, do you have a question?
I just forgot to log off.
Okay. Everything's okay so far?
Yep.
Okay, good. See you at 12:30 or before.
Yep.